Welcome. This is the second set of notes for this unit. We'll be talking about synthesis and decomposition reactions today. Our objective, again, is to compare and contrast these and also to solve problems and identify whether an equation is a synthesis or decomposition reaction. There are 5 main types of chemical reactions. Today we'll be covering the first 2, which are synthesis reactions when we have 2 or more reactants and we combine those or synthesize them to create one product. The flip side of that, comparing that, is decomposition. And as you may remember, if you've had biology, decomposers, they break things down. So decomposition reactions are when you have a single reactant and it decomposes or breaks up into 2 or more elements or compounds. The other 3 types of reactions, the single replacement reactions, double replacement reactions, and combustion reactions, we will cover at a later time. So let's get started on the first 2. The definition for a synthesis reaction is a reaction in which 2 or more reactants combine to form a single product. In simple letter terms, A plus B yields AB. Now, it's important to note here, maybe highlight this or star it, A does not have to be a single element. It could be a diatomic element like O2, or it could be a compound like a hydroxide, an OH, or SO4 or SO3, but it is a compound or a single element, and we will combine it with another compound or another single element. The basics are the same. You have 2 separate compounds or elements, and they are united into a single product. So here's a visual for you. If you have carbon and oxygen reacting together, you get CO2. Here is a diagram or a picture that might help imagine what's going on here. So in our photographs, we have potassium metal, which is this silver shiny thing in the beaker here. And if you take a close-up molecular view of the potassium, it's lots of single potassium atoms all together. And then you have in this glassware here, you have a gas. It's a yellow gas and it is chlorine. And chlorine is a diatomic element, meaning it's not found by itself in nature. So you see that represented here with 2 chlorine atoms, and it's a gas, so our representation looks like they're flying all over the place. If you add these 2 together, so what they've done is they've taken this potassium metal and they've put it inside this glass jar, and there's a reaction taking place. If you remember back last semester, evidence that a reaction is taking place are color changes, a precipitate forming, so a solid coming out of this, and what you end up with is all over the glass you have a salt. Now a salt is the potassium and the chloride. You notice the potassium's positive, so it donated an electron to the chlorine, and the chlorine is now negative, and they stick together in this crystal structure. This is a synthesis reaction because we have one element here, another element here, we combine them and we get a third and single product, which is potassium chloride. It's just another way to visualize the synthesis reaction. So if we're going to solve problems, synthesis problems, first we have to identify what type of reaction it is. As we go through the notes, you will learn all 5 types of reactions, so looking at the equation, you'll have to identify the type. Is it in fact a synthesis reaction, or is it a decomposition reaction? After that, you'll predict the products by using the type of reaction as a model. One thing that's important is don't forget to use the periodic table to make the correct ionic compounds. We spent a lot of time last semester talking about the rule of 0, where when you add 2 ions, if 2 ions are going to form a compound, they need to their charges need to add up to 0, and you'll see that as we go through the example problems. After you create the correct ionic compound, you make sure the equation is then balanced. One thing that we haven't spent a lot of time talking about, but I want to point out, there are diatomic elements, just like the chlorine in the last example. Here it is. It doesn't exist in nature by itself. It will always be a di, meaning 2, atomic, meaning atoms. It will always have 2 of them. So for example, oxygen will never be found as just a single oxygen atom. It will always be found as O2. For my students, I will give you this list. I'm not requiring that you memorize it, but you do need to know what to do with them. So, let's take a look at these, and let's do the first one together, and then you'll pause the video and do the last 2 on your own. So we look at sodium, and the first thing we have to decide is what type of reaction is this? Well, I've told you it's going to be synthesis. So then we have to make sure we make the correct ionic compound. And we have to look at the charge on sodium. So go back to the periodic table, and what will be the charge on sodium? If you set a positive 1, you're correct. So we have +1 here for sodium. What's the charge on chlorine ions? If you go back to the periodic table and you take a look, chlorine is -1. So when we put these 2 together, we'll have a +1 and a -1. There it is. The third step is to see if this equation is balanced. Is it balanced? I hope your answer was no. So what can we do to balance this equation? And the answer is to put, The answer is to put a 2 here in front of the NaCl. That will give us 2 chlorine atoms, but it also gives us 2 sodium atoms. So we would put a 2 in front of the Na here. So pause the video, and when you finish, start it up again. Great, welcome back. So hopefully you have this for your answers. I would be more than happy to go over these with you if you need some help. But otherwise, pause the video, take a look at what you did, and if you got the correct answer. Our next type of chemical reaction are decomposition, or breaking up, or breaking down. Here's the definition. A reaction in which one reactant separates to form 2 or more products. So again, in our AB format, we have our compound AB. We're going to decompose it. We're going to break it down into A and B. Now my note from the synthesis reaction still holds true. This could be a compound like SO4, and then you would end up with SO4 here. It doesn't have to be just a single element. Although, my example here, NaCl, which is table salt, sodium chloride, is a single element. So here we have our table salt, and in a decomposition reaction we will separate those. Here's a visualization. So here we have mercury oxide, which is a solid. It's this big lump here, and it's a crystal structure like this, with the red representing our oxygens and the Hg representing our mercury. When we add heat, so you can see in our reaction here we have an over a Bunsen burner, so you see the heat here. You're seeing a color change occur. What's happening is as you heat it up, the oxygen is becoming a gas, an O2 gas. It's being released out of the top of the test tube, and what you're left with in the bottom of the test tube is that mercury, that liquid metal that we know from thermometers. All right, let's solve the problems again. Again, identify the type, predict the products, making sure that if you're doing an ionic compound, the rule of 0 charge is upheld, and then your final step is to balance the equation. And once again, don't forget about your diatomic elements. So let's try this one. Lead 4 oxide decomposes. So here's our lead oxide, Pb, and O2. And we know we want to break it down into a single Pb and O. Our O2 is still an O2, so the last part of solving our problems is to ask if this is balanced. Is this balanced? We have one lead atom and we have 2 oxygen atoms, so yes, it's balanced. Moving down to number 2, aluminum nitride decomposes. So we have aluminum, which is Al, and we have nitrogen. So we're going to break this down into Al plus N. Now N2 is one of those elements that has to be diatomic. We have to have 2. It can't be by itself. So our formula for N has to be N2. The final step is to balance this equation. Is it balanced? We have 1 aluminum atom, so that checks out. We have 1 nitrogen atom over here, and we have 2 over here. So we're going to have to adjust this a little bit. So if we add a 2 here, that changes this to 2 nitrogen atoms on this side, and we have 2 nitrogen atoms on this side. It also changes our aluminum, so we have to add another 2 here. All right. If you have questions about any of the example problems or would like to work through them with me, I am here and available. There is a homework worksheet on Moodle. It's called Synthesis and Decomposition Practice. I also put up a challenge page for you that's worth some extra bonus points on your test. Email it to me and I'll look it over and respond.